why actually are we moving to EV nowadays? Right. First of all, let's talk about it because we have conventional vehicle for so long till now. Conventional, if okay, this is a mystery to you guys. I'll tell you about a fun fact in this webinar also. So, according to all of us, EV is a new technology, right? EV is a new technology. It's emerging right now, right? So, and if it is new technology, petrol, we are using petrol since so long, right? So why are we spending so much time? Why are we doing so much efforts in learning more about EV, hybrid powertrain, when we already have a stabilized ecosystem of our gasoline vehicles, right? So you see the price of the gasoline. It's somewhat hundred rupees per liter, and our car or any car, let's say, it gives an average of 15 kilometers per liter, right? So, because of the cost factor, first of all, and we all know that the petrol is depleting, right? The petrol is depleting, and also the main reason to shift from EV to shift to EV is because of the centralization of the petrol to Middle East country. To Middle East centralization. All the companies like Qatar, UAE, they all have the access to the oil wells. But none of those countries, and they are those countries are the ones that are actually regulating the price of these or of the petrol. They can increase the price, they can decrease the price, be like right now Ukraine also had access to petroleum, right, to petroleum wells, and with the current events of UK and Russia, so how much the prices has gone up, especially the natural gas prices, right? So because we want to become independent of this Middle East centralization of cost, so that's why we are right now moving towards the EV sector, right? And coming to one other fact that I want to put up right now is first, let's move to electric vehicle, right? So you guys tell me, if I'm asking you what an electric vehicle is, so tell me what is an electric vehicle. Define electric vehicle. You can type your answers in the chat box. Come on, like first. What are the components of an EV? Yes, fast type. Yes, replace engine with motor, battery pack. Yes, keep coming. Engine, battery in the engine, or prime mover with motor. Battery, motor, it works with electricity from battery. Okay, if I ask you that this is working on electricity, right? But for creating electricity, I am again burning up the coal. Then what is the use for going to EV? Just tell me this. Let's see how many people can answer this question. Okay, keep the answers coming, right? So we have got batteries till now. The answer is battery. The answer is motor. Okay, I have also seen electronic. Someone said electronic. Yes, and regenerative braking. Energy carries electric to mechanical. We use renewable. Yes. Noise pollution, renewable energy. Yeah, that's the answer. Yeah. To reduce carbon emission. Ritesh, that's what I'm asking. That if you are saying that you want to reduce carbon emission, how are you reducing the carbon emission? Right? You are again burning up the coal for production of electricity. So how are you reducing carbon emission? Yes. So the answer is to switch to renewable sources of energy. Yes. So what are the renewable sources of energy? Be it solar, be it wind, okay, be it hydro. So these are our renewable source of energy. So only EV are only successful if we are switching to renewable source of energy. And all the answers that I have got till now, biomass, biogas, yeah, very good. Keep it coming. Right. So let's talk what are the components of EV. Let's see in this picture. So first, of course, starting up with the charging port. Starting up with the charging port. So first, what I need is I need to charge my electric vehicle first. Be from any source of energy, right? Be it from, let's say right now we are using coal. We are producing electricity from coal. We can produce it with wind. We can produce with hydro. Okay, but we need energy, and we have to fill our vehicle. We have to fill our battery with energy. So first we need charging port, and then we need batteries. Batteries, what are batteries? Batteries are electrochemical devices that actually stores electricity. Okay, so that's what the use of battery. Battery is actually a electrochemical device. Okay, so someone is using mic. I guess I request you all to mute your mics. Okay. And yeah, we have 245 people with us. Nice, keep it coming. 246. Guys, share the link for the webinar. This is a free webinar, and you'll get certificate also. Okay. Yeah. So we have got an answer. Lingam Pali, he says converts chemical energy to electrical energy. Very good. So that's the use of that's the need of our battery. Battery, what it actually do, it converts electrical to chemical or chemical to electrical energy, right? So that is the use of our battery. It is an electrochemical device. Then I have stored enough battery. Okay, my battery is fully charged, but I have to propagate my vehicle in forward direction. I have to move my vehicle, right? So so battery actually stores my energy in DC. Okay, battery stores my energy in DC. But nowadays we are using AC motors in our vehicle. Okay, we are using AC motors. So we have to convert AC into DC. Right? We have to convert AC into DC. That's why we need a converter. That's why we need a converter. Okay, and when this this DC is converted into AC, right? Then it goes to the motor, and then motor rotates and it gives power to our output, right? In between, for charging my battery, I need a BMS. A BMS has to be there. BMS and BTMS. BMS and BTMS. BMS, what is BMS? Come on.
Battery
management system. Yes, Sagar, yes. Battery management system. And what is BTMS? What is BTMS? Battery thermal. Yeah, tell me the full name. Half name won't be considered. Battery thermal management system. Yeah, exactly. So we have got BMS, we have got BTMS. But what is the role of BMS actually? BMS actually, it is used so that, like, I have got so many cells in my battery. Okay, you have studied in your previous classes also. This is the symbol of a cell, a single cell, right? But if I combine two more than one cell, even if we are combining two cells together, then it is a battery, right? So if we are connecting these two cells together, they will get charged and discharged at a different rate. Right now, I'm just taking an example of two batteries, two cells. Suppose, like in Tesla, we use somewhat around 700 cells. 700 cells. So every time when I'm discharging or charging the cell, they have to get charged or discharged at the same rate. Otherwise, one cell will overcharge and one cell will undercharge. Right? This will cause battery failure. So to check this, to maintain same SOC throughout all the cells, we need battery management system. Right? Also, also, we need BTMS. BTMS is battery thermal management system. So what's the role of BTMS is while charging or discharging the battery. While charging or discharging battery, okay. So my electricity, my electricity is higher grade of energy, and when I'm storing it to my battery, when I'm storing it to my battery, it gets converted into chemical energy. It is a lower grade of energy. So in this entire conversion, there are losses. There are losses. Losses, be it thermal losses, hysteresis losses, hysteresis, EMF, electromagnetic losses. Okay, electromagnetic losses. So while charging or discharging the battery, my temperature of the battery changes. It sometimes goes. It actually always increases. Okay, you have experienced this while using your cell phone. Okay, when you are playing PUBG for more than a hour, more than 1 hour. Okay, then you will see that your phone is so hot that it can be actually used to iron clothes. Right? If it is not a good phone. Otherwise, you need iPhone. Okay. So yeah, Sagar, yes, eddy current losses, very good. Keep it coming. Avoid thermal runaway. Prashant Stele. Yes, yes. So that's why we need a battery thermal management system also, so that we can regulate the temperature of the entire battery. Okay. So moving on to history of the electric vehicle. Okay, I will not make it boring. Okay, histories are always boring. I know. Okay, trust me, I'll make it interesting. And I've just picked up few interesting facts out EV that that will increase your curiosity about EV. Okay, so I told you earlier that first EV, that gasoline vehicle came earlier before, like came before EVs, right? Just a second, guys. Just hold on a minute. Yes, so I was saying that I'm going to tell you about the history of the EV. So I told you earlier that that gasoline first came in, right? So actually, first electric vehicle was actually made in 1830s. In 1830s, right? So Robert Anderson, he created the first electric vehicle, and then in 1856, the invention of lead acid battery. Lead acid battery is a renewable battery, right? It has advantages like it is less toxic, it doesn't have memory effect and other aspect. So because of the invention of lead acid battery, EV got more into the public use. Okay, EV was more popular at that time. So in 1890s, EV made their use to public.
Good evening,
Public.
sir.
Yes. Good evening. Hello. Who's talking? I'll request you all to if you have any doubts, you can use the chat box. Okay, we have 283 people with us. Okay, so you can use just use the chat box and just mute your mic. Okay. So yeah, we were talking about the history of the EV. So yeah, in 1890s, in 1890s, EV made their ways to the public use at that time. Okay, and this is a fun fact. In 1900, in 1900, 4,200 vehicles of 200 units of automobile were sold, and out of those 4,200, guess what? 40% was steam powered. 40% was steam powered. 38% was electric power. 38%. Gasoline was just 22%.
Excuse me, sir, you are not audible. Hello, sir.
Sorry guys, am I audible right now?
Yes, sir.
Yes, sir.
Okay, 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 okay. You could have just used the told me earlier. Nevertheless. Okay, so what was the last thing that I said?
Sir, partition of gasoline engine and EV engine and steam engine.
Oh, okay, okay. So yeah, I was telling you that at that time, gasoline engine. Okay, actually, someone muted me. That's please don't do this. Well, well, yes. At that time, gasoline engine were sold less than electric vehicles.
Sir, you are not audible again.
Well, someone is muting me again and again. I request the admin to kindly check this issue. Someone is muting me again and again. Can't every just can we just make can we just make every other person attendee in this meeting? Someone is messing up with the session is going
सर एक
great.
क्वेश्चन पूछना था सर.
Yes, you can just use the chat box. Okay, let's not stop in between. These ups and downs will come. Okay. So yeah, and then later on, yeah, I was telling you that everything was going great with electric vehicle. The sale was high, the production was good. Again, someone is muting me again and again.
Sir, please
Raja.
throw him out.
If I know who is muting me, then I will of course block him.
Yeah, rapidly
Just a
is doing the
second, I'll
thing.
just contact the admin and he'll fix it. Just a minute.
Okay.
Okay. I've contacted the admin. The one who is doing it, he'll be banned from ISI lectures now. Nevertheless, Raja Raj, sir, classes will be held every day. No, dear, classes will be held on weekly basis. Right. We'll have webinars every Saturday. So now moving on. So what gave a major blow to the production of EV? Everything was going good. But hello. Okay. So everything was going good, but the drawbacks of EV at that time was first of all the less range, right? The range of lead acid battery is not that good. Second, the toxicity that lead acid battery have, this toxic feature, right? And third, EV were very expensive. Yeah, weight also. Well, we can't consider weight because at that time also we were having V6 engines. V6 engines are very heavy. Be it Rolls-Royce, be it Mercedes at that time, they were having less speed, but they were using V6 engine, and they are pretty bulky. So weight is not that much of a factor. The factor are majorly because of less range and speed, right? And at that time, the thing was at that time electronics were not that developed. Electricity availability, yeah, we can say, but at that time, everyone that were buying vehicles, they were pretty rich. They must have had access for electricity. But yes, we can say electricity must have been a major issue. Efficiency. Well, yes, there are many. So, but then the major blow came in 1908. In 1908, when Ford company, the owner of the Ford company is Henry Ford, right? He then started mass producing our Model T, Ford Model T. And you know, whenever we do mass production, the like mass production is done basically like we reduce the number of man and we increase the number of machines. The conveyors are being used, right? So that's why the cost, due to the mass production, the cost of the vehicle got down. When the cost of the vehicle got down, so in 1912, because of mass production, you can see that gasoline car was sold for $650. Electric car was sold for $1,750. Why will I buy electric car then? Right? When it is giving me less range, it is lead acid battery, it is expensive, and at that time gasoline was easily available, it was cheap, right? And yes, hello. Nevertheless, okay. Now, one major issue with gasoline car was that it was not self-start. It was not self-start. Okay, those who might have been gone to their hometowns or are from somewhat like farming background, right? They must have seen old tractors these days. In old tractor, let's say, let me make a representation of a tractor. A tractor somewhat, I don't know, I am bad at drawing. Okay, don't judge me. Okay, this is how a tractor somewhat looks like. Okay, so in old tractors, what we used to have, there used to be a crank over here, a lever, a crank, whatever you call it. It used to be there. We have to rotate it manually so that our vehicle can start. Right, you have to rotate it manually because there were no self-starting mechanism at that time. But in 1912, Charles Kettering, he introduced the electric starting. He introduced self-start. Okay. Now, before the introduction to self-start, the females who were driving, they used to prefer EV because they don't have to do manual work while again operating, like when they have to drive. Like the females are, of course, they have class, right? They have class more than us, right? They have class. They don't want to do manual work. They want automatic start. EV provides automatic start. So that's why EV was popular till electric start was developed. But then, but then EV disappeared in the market. In 1935, EV got disappeared. But then in 1970s, we came across the pollution issues. We came across so many global warming, the depletion of ozone layer, and what all things, right? So that's when 1970s the research on EV started. It resumed, and then in 1995, General Motor it introduced its first vehicle, electric vehicle, that was EV Saturn EV1. Okay, but it was just limited to the market of California and Arizona. Right. In 1990, Toyota introduced its first hybrid, Toyota Prius. Okay. So this was all about the history of EV, and now we all know EV is seen everywhere. The legend Tesla, right? The dream company for every students who are in this workshop. Let me tell you one more thing. One of our guy who did he participated in ESVC, and he did our course on electric vehicle, the powertrain course. He got placed in Tesla. I just wanted to share this news with you. He got placed in Tesla with all the knowledge that he learned from these classes and the courses. Moving on, so this is a piece of history that you can see. This is a fun fact because the wife of Henry Ford, like the founder of Ford Company, known for its EcoSport, Endeavor, Mustang. Okay, like so powerful cars and most reliable cars. Okay, his wife used to drive an electric vehicle, despite of the fact that at that time Ford Model T was there. So as I have told you, that electric car appealed to female audience more because they have class. They don't want to do manual labor. They want easy operation, and they want cleanliness, right? So that's why Clara Ford, the wife of Henry Ford, used to drive an EV. And at that time, when EV was not that popular, like the sales were increasing, but they were not that, like you can see the date in written here, 1950. And in 1912, I told you, in 1912, electric starter came. So as electric starter came, the sale of EV declined, right? So this letter is written on 1950 after electric starter came. Okay. So Anderson Electric. Okay, Anderson, I've told you, the guy who made the first electric vehicle in 1835. He wrote a letter to Mrs. Ford so that like she can suggest the electric vehicle to some of her friends to buy this vehicle and make it more popular. Okay, so this is a piece of history. You can see this letter. Okay. Now let's talk about the plus and minus of EV. Let's combine EV or hybrid in this slide. Okay, what are the plus and minuses? Okay, so first plus is the lower emission. Okay, first plus is the lower emission. And when I talk about lower emission, I mean that I am using renewable source of energy. I am using renewable source of energy. Right. If I am using again coal to burn or gasoline to burn the vehicle, then what is the need of lower emission? I am getting the same emission, right? So that's why renewable energy first is needed. Then again, I have told you we have to reduce the dependence of fossil fuels to the West Asian or the Middle East countries, right? All the or the Kuwait and UAE and other countries, because they are regulating the fuel prices. Right now, petrol is being sold for for rupees 100. They can easily, like they have the source, they can easily increase this price to 200 rupees. They can increase the price of the supply. Then what can government do? How much subsidy can they do? Right. Right now we are blaming Congress. Right. We are blaming BJP that they are increasing the price of fuel. How can you blame them? The price of fuel at when Congress was there, so the raw price was pretty less. Now these Western countries, Middle East countries, they have increased the price. So how much subsidy can our government give? Okay. Again, then we have energy efficiency. Okay, this is something I want to talk about. How is EV more energy efficient? Okay, so I have electric energy.
What?
Electric energy is higher grade of energy. Okay, I want to convert it into mechanical energy, which is a lower grade of energy. This conversion will of course be more efficient, right? Rather than rather this conversion is seen in EV. Okay, this is I'm talking about EV. Okay, now let's talk about our petrol or gasoline. Okay, in gasoline, first we have chemical energy. First, we have chemical energy, like the calorific value. You have heard about Have you heard about calorific value? Keep the replies coming in chat box. No, you haven't heard. Yes. Okay. Sagar hasn't heard about calorific value. Harsh, tell him about calorific value. Abhishek, mechanical boy, tell him about what is calorific value. Help your friends right now. Okay. Okay. So he'll tell you about calorific value in the chat box. So converted into heat energy. This heat energy then will be converted into mechanical energy. Okay. So in this entire conversion, like heat energy is lower grade of energy, mechanical energy is higher grade of energy. So this conversion, we have so many conversions. This will be of course less efficient. So that's why the efficiency of electric vehicle is more. Right now, I'm just talking about electric vehicle. I'm just talking about electric vehicle. I'm not talking about the entire process. There are two things: well to wheel efficiency. First is the well to wheel efficiency, and in well to wheel efficiency, we have two bifurcations. We have well to tank and tank to wheel. This will be covered in future classes. So I'm just giving you a brief idea what it is. Then we can use regenerative braking. We can use regenerative braking in EVs. So first of all, when I brake, you have seen in disc brakes, right? When I brake, so what happens is, like if I am driving my car and I am coming from a speed of 100, I stop the car, I apply the brake, then the speed will decrease, my vehicle will come to halt. Then if I go to my disc, the vehicle disc, and I then sprinkle some water on it, the water will, it will like dance, like I have sprinkled water on a dosa pan. Like that's how it will dance. The water will dance over there, right? Because it has become so hot, the mechanical energy got converted to heat energy. And in regenerative braking, I am converting that mechanical energy to electrical energy for my own use. So that's why we can use regenerative braking. And also it is quite an operation. Like every EV is quite. Then the disadvantages, of course, the disadvantages. First is foremost limited range, but we can't say this again, limited range nowadays. Even Nexon EV is saying it has a claim range of 500 something kilometers right now. Okay. So limited range is it's not an issue nowadays because the range we are getting on a full tank of a normal petrol vehicle, we get the same range in EV. But the problem is charging infrastructure. The time charging infrastructure and the time that is taken, that's of course the problem. That is the problem. I have to stand in queue, I have to wait so long, and all these things. So that's the problem. Cost. How is cost a problem? Well, you are. I'm telling you, per unit energy of 1 unit energy, 1 unit energy in UP, Uttar Pradesh, it costs somewhat around 5 to 6 rupees. But 1 liter petrol, it is giving me a cost of somewhat 1 liter is 100 rupees. So how is this expensive? I am going to a cheaper alternative, right? But no, the initial cost is very high. I can get a Nexon EV, Nexon EV for 8 lakhs, the lowest model. The lowest model can be obtained for 8 lakhs. No, not Nexon EV. Just Nexon petrol version, base petrol version for 8 lakhs. But Nexon EV, I have to give for the base version somewhat to 15 to 16 lakhs. So the initial cost of investment is pretty high in EV. Okay. And then the performance, right now, no, performance is also not a big issue. Right? Performance, if I say in electric, you have battery operated vehicles like you have seen e-rickshaws, okay, and mini metros, you have seen mini metro e-rickshaw. I can say performance is an issue over there, but no, right now we are having high specification motors. The synchronous motor we have reluctance motors, they give very nice performance. Now coming to the types of electric vehicle. Okay, yeah. Everyone is giving answers. Calorific value refers to the amount of heat produced by a unit volume of substance by complete combustion. Yes, Nipun, your answer is right. Nice. Okay. Kinetic energy converted into potential energy. Right. Regenerative braking energy. Yes. BLDC motor. TKM. Nanda, what is TKM? Explain it. Feedback link. Why is it so bad? Is it so bad that you want to give feedback? Okay. You can give your feedback in the chat box only if you want. Okay, now we have 290 people with us. Let's make it 300, guys. Share this link to everyone. We'll talk about EV. We are coming to EV architecture right now. Okay. Let your friends also gain some knowledge, some insight about EV. Okay. Now coming to the types of electric vehicle. So first is of course our BEV or battery operated vehicle. BEV, battery electric operated vehicle. So okay, the time is getting low. It's 5:40. I have to wrap up before 6. Okay, no worries. We'll just move a bit fast now. So in electric vehicle, what actually is electric vehicle? I'll just tell you that I just give the input that is given to my electric vehicle is electricity only. That's it. I just charge my batteries will run the motor. That's it. As simple as it can be. Okay. I've already told you electric motor is there. Electric motor, of course, for running the vehicle. Inverter is there. I told you AC to DC conversion or DC to AC conversion. AC to DC, DC to AC. DC to AC when I have to give supply from battery to motor. And AC to DC when I am using regen. Okay. So battery inverter I have to use it. Battery I have used control module. We'll talk about control module also. Control module is basically the heart of EV. HEART, heart of EV. It is basically the heart of EV. Okay, everything is controlled with control module, right? Then we have the drivetrain. We also have gearboxes in our electric vehicles. Okay, one stage, two stage gearboxes are there. Okay. Also, I'll tell you a fun fact also. Fun fact, EV actually don't come with gearbox or they don't have gears. They mostly single stage reduction is enough for EV. But if I use gearbox in EV, it increases the efficiency of EV. It actually increases the efficiency of EV. This has been done and solved in MATLAB, and it has also been practically proven. Okay, so we have talked about this more on our courses. So let's right now just stick to our topic. Okay, now it's time for hybrid electric vehicle. In earlier in battery operated vehicle, my input, what was my input? My input was normal electricity. But in hybrid electric vehicle, my input is actually the fuel. The fuel, okay, where is that? Okay. I fill up my fuel tank with fuel, be it petrol or diesel. I fill my vehicle, and when the motor drives, then in like engine uses fuel to burn to for combustion, right? Engine uses fuel for combustion. It supplies some of its energy to motor that acts as a generator and produces electricity and stores electricity to the battery. That's it. And that battery can also be, and when we need battery, it can easily move our vehicle, right? So coming to its components are engine, electric motor, battery pack, controller, inverter, fuel tank, control module. Only thing that has increased is first of all the engine is here, engine and our fuel tank. Rest everything is same in BEV and HEV. Okay. Moving to PHEV. Moving on PHEV. PHEV is combination of hybrid as well as EV. Okay. Hybrid as well as EV. So in PHEV, PHEV stands for plug-in hybrid electric vehicles. Plug-in hybrid electric vehicle. So in PHEV, I give fuel to my vehicle. I fill up the tank. I do fill up the tank. But I can also charge my battery externally. In HEV, I was not able to charge battery externally, right? But in PHEV, I can charge my battery externally. When I charge my battery, I can charge my battery externally. While regenerative braking, again my battery is getting charged. My fuel can be also used for combustion. So I don't have any limitation for range in here. Okay, I don't have to wait every time for my for charging my vehicle. Then electricity will kick in and start the motor, and then I'll get high performance and everything, right? No. In this, I can charge my vehicle from fuel or external energy also. The components are the same. Components of PHEV and EV are same, plus charging. I need charging infrastructure in my car. In my car, outside, anywhere, I need charging infrastructure. And then we come to FCEV, that is fuel cell EV. In fuel cell, it's basically hydrogen fuel cell. Hydrogen, it's a new technology. It has its plus and minuses. Again, right now we are not talking about it. Right? You can see in the figure that I am filling the hydrogen tank with hydrogen. Right? Then that hydrogen is being used by my fuel cell. The working of the fuel cell can be like, there are multiple courses in the website. You can check it out. It has been more explained by professional trainers over there. They have far more knowledge than me, so they'll tell you more about it. Nevertheless, so fuel cell then it converts the hydrogen into electricity, and this electricity is stored in the battery or used for driving the motor according to the need, and the motor will run the vehicle. This is about my types of electric vehicle. Moving on to the main topic of the evening, hybrid electric architecture. Okay, let me see what is there in chat box. Okay, okay. Sir, can I get your email ID? You can just use, uh, you can contact ISI. They'll let you contact me. Okay. Okay, we have 301 people. Guys, keep it coming. 302 people. Nice. I want to know more about drivetrain. Can I get your number? Oh, of course you can. You can just contact ISI. I am part of ISI. We are a team, right? They'll let you contact me then. Okay. Onboard charging. Exactly. Sagar is telling the right answers. Onboard charging should be present in our plug-in hybrid. How to implement regenerating? Okay, I'll throw some light on it. Is used charging. Sir, will the session goes every Saturday? Yes, it will go every Saturday. How can I connect with you? You can just connect with ISI. They will let you connect with me. No worries. We are here. We are together. Learning. Focused on learning. Okay. Sagar is good. Yes. Res Rastija. Sagar is good. He's a good boy. Okay. Now let's talk about again the main topic of the evening. Okay. Our guest, hybrid electric architecture. So in hybrid vehicle architecture, it is basically categorized in three ways. Okay. You must have heard about parallel hybrid. Some of you might have heard. You must have heard about series hybrid also. Some of you must have heard about series and parallel hybrid also. But I'm damn sure no one would have heard about series parallel 2 into 2H. This is not so common. Okay. With our team's intense hard work, we do this. We collect informations for you guys. Okay. Now coming to the degree of hybridization. For degree of hybridization, I have micro, I have full hybrid, and then have mild hybrid. I have three types of electric vehicle in terms of degree of hybridization. And based on transmission assembly, I have two: post-transmission hybrids and pre-transmission hybrids. Moving on to our first is also running. Battery is also making the motor move. Okay, both are running. Then here, both of them are supplying power to my transmission device. And there is a coupling device also that is blending the power of both engine and batteries at the same time. And then this power is being transferred to transmission device, then to drive shaft, then to differential. As simple as it can be. Okay, both of them are coming together and giving the power. Now the main question is how, where is my pen? Yeah, here it is. Main question of the evening is how am I blending engine power and motor power? You just tell me in the chat box. I'm waiting. This is the question. This is a pretty hard question. If you know the answer, sir, you left two questions. Please explain. Yes, I'll explain it, dear. No worries. First, let me just finish the slides. Okay. Now the example of parallel hybrid is first of all Honda Insight, Honda Civic Hybrid. Okay, Honda Civic Hybrid. This is in recent news. It is very popular nowadays. Honda Civic Hybrid. People are going to Indonesia to drive this vehicle and give us reviews. Okay, I have seen people going to Indonesia and drive this vehicle. And then we have Mercedes-Benz S400. This is the example. Talking about the advantages and disadvantages of this vehicle. Okay. So advantage is that we need, of course, two proportional propulsion components. First is the IC engine, other is the motor. Okay. Then in parallel, I can use motor to generate electricity. I can use it as a generator also. Also, the thing is, why, like, I am using engine also. I am using EV, like motor also, motor and battery. If I'm already using engine, then how am I supposed to save the and lower the carbon emissions? What is the use, right? Well, the use is, let's say my engine is producing like, let's say I was having, just this is an numerical rough data. This is no exact data. Okay, let's say I am telling you about shift. Okay, shift has its petrol version has a 300 1300 cc engine. Okay, it produces a power somewhere around, I don't know, uh, how much does shift produce power? Okay, tell me in the chat box. Come on. I guess near about 90. 90 should be the figure. I don't know the exact right now. Tell me in the chat box fast. I'm waiting. Come on. Where is everyone? Where is mechanical boy? Where is Sagar? 90 bhp. Engine is high, so weight of the vehicle is increasing. Yes. 90 bhp, 75. Yes, it is 90. It is 90, 75. Okay. It is 90. Most of the answers are 90. Okay. 93 bhp. Okay. My 1300 cc engine is giving me 93 bhp power. It is giving me 93 bhp power. Why I am shifting to hybrid is that now I can downscale my engine. I can downscale my engine to, let's say, 700 cc. I am downscaling my engine, so it will consume less fuel. It will consume less fuel. It will lower down my energy consumption, lower down my emission rates, right? And then motor, for the rest, for the remaining 13 minus 7, which is 600, the power that will be produced by 600 cc engine, I am using a motor to produce that power. That is the basic concept of a hybrid. Hope you get it. Yes, 90 bhp at the rate 6000 rpm. Yes, precisely. Okay, hope you get this concept. Okay. And also, the advantage of parallel hybrid is, if my batteries are drained out, then I can just run my vehicle on engine. I can just run my vehicle on engine and, yeah, just turn off your mic, please. I request you to turn off your mic. Yes. Okay. Now coming to its disadvantages. Disadvantages of using a parallel is the complexity and the power blending mechanism. Again, this is a mystery till now. No one has answered it. How the power blending is done between motor and engine. This is a mystery. Tell me. Use the chat box to answer it. So first is the disadvantages. The disadvantages first is the complexity. Okay, I need ECUs. I need ECU, electronic circuit, and everything to control all the sensors, to maintain the RPM of engine, to control the RPM of the motor, supply of the current, supply of the voltage. Everything has to be controlled. It makes entire algorithm so hard, right? That's why these are the disadvantages of parallel hybrid. Moving on. Okay, we got an answer. We got a transferring power from flywheel to motor. No, dear. That's not the answer, Will. Through vehicle power management system. That's what I'm asking you, Gunjan. That's what I'm asking you, that how is this power management system works? What is inside? Yes, power splitter. But how does this power splitter works? Tell me about that. Moving on to series hybrid. What is in series hybrid? Okay. So in series hybrid, what we do, is our engine. I'm giving fuel to engine. Engine is working. Okay, engine is revolving. It is rotating. It is rotating the flywheel, everything. This energy is then given to my generator, and this generator, it then uses the mechanical work that is done by the engine, and it then converts it into electrical energy. This electrical energy, some of it is stored in batteries. Okay, some of it is gone to the motors, and then again from motor to drive shaft to differential. Okay, this is main working of series. It is simple. It is very simple. I don't need a coupling device here. No torque, no power coupling is required here. It is very simple. Okay. Now, the examples of it is Honda Civic CMA, Toyota Prius, the first HEV, and Lexus RX 400H. I think Lexus is under Tata, if I'm not wrong. Correct me if I'm wrong. Okay, I'm getting some answers. I'm getting answers as generator, battery, no. Toyota, okay, Manal. Okay, Lexus is under Toyota. Yes, got it, yes. No, it is under, no, it is under Toyota. I remember it. I saw a session of Toyota. Lexus is under Toyota. Lexus, yes, you are right. Lexus is under Toyota. Moving to series parallel hybrid. Now I am getting the best of both the worlds. I am able to take advantages of series and parallel both. Okay, let's talk about the theory. So it is capable of providing me continuous high speed power, right? And also with a reduced size powertrain. Okay. With series, what I can do is I can operate my vehicle either as series or as parallel, or as both, or as just IC engine, or just as electric vehicle. I have so much flexibility.
Hello, sir. You are not audible. Hello.
Okay, I'm now audible now. No
Yes,
voice.
sir.
Yes, sir.
Arey, someone is muting me again and again. Curse him, everyone. Your curses will reach him. Okay. So what I was telling you about, what is the last thing that you heard? Probably I was telling you about planetary gear set, yes? So I was telling you about the power. I was telling you flexibility. Yes, I was telling you about flexibility. Yes. So in terms of flexibility, I can use my entire, okay guys, this is disappointing. The people are going 291. We were having a crowd of 300 people. Share this link. Okay. Now I was telling you about power blending. In power blending, how it is done is you must have studied, if you're a mechanical engineer, about ring planet gear arrangement. Okay. So we know a basic theory that sun is in the center. We have planets. Planets, it revolve and rotate around around the sun. We know this theory. Similarly, our ring planet sun arrangement works. I have a sun gear in the center. I have multiple planet gears, and I have a ring gear. Okay. So right now I'm not talking about which thing is like I have in a hybrid vehicle. In a hybrid vehicle, I have input. What are my input? My input
Sorry, sir, again you are muted, sir.
Someone is again and again muting me. I don't know the one. Time is running out. Yes, yes, yes. Okay. So I was telling you about that I am having two inputs, engine and motor, right? I want to give one output to the drive shaft. I want to couple them in here in my ring and planet assembly. In ring and planet assembly, what I have is I have a ring gear, I have planet gears, and I have sun gears. I can couple, let's say, my ring gear to my engine. Then I can couple my planet gear to, let's say, motor. Combination of both the power will be obtained at the sun gear. That's how my entire coupling works. So this is about the power split device that I was asking you that tell me how the blending is done. This is how the blending is done. Okay. So example of series parallel hybrid is my Charlotte volt. Okay. Now moving on to both series parallel 2 into 2 hybrid. Okay. You must have heard about Thar 4 into 4 four-wheel drive, right? Now I'm talking about series parallel 2 into 2. What does this mean? Well, in 2 into 2 hybrid, what I do is my front axle and I have two axle, front axle, rear axle. Okay. I can connect my front axle to to my engine. I can mount my rear axle to motor. Okay. This is how how I mount, and both axles are live axle. Yes, you are precisely right, Prashant. Very good. Okay. Okay, right. Precisely, you are right. Okay. Someone wants to join the meeting. Sumesh, yes, admit it. Admitting. Okay. Okay. So in engine, so that's the basic of our hybrid, this 2 into 2 architecture. So I have my IC engine. IC engine, it directly gives first power to my front axle. It is coupled with my generator. This generator is then coupled to like other accessories, also the battery, and also my motor. According to the power usage, here I have my DC bus. DC bus. So DC bus is basically, it is used for intra-vehicle communication. It is basically used for intra-vehicle communication. And okay, people wants to come in, admit all. Okay. Okay. So intra-vehicle communication, for intra-vehicle communication, DC bus is required. So according to where the power is supplied via generator. So during the acceleration, the engine power in the front wheel can be used. Okay. And when like I need peak acceleration, then what I can do, normally my engine are working. It is working, it is transferring the power to the front wheels. Okay. Okay. Where are the admins? Where are admins? I am getting distracted by this. Again, and people are coming in. I am getting distracted. No, not G. I'm not talking about G. I'm talking about the people that want to enter in the lecture. Okay. So what I was telling you, that Normally, okay, again someone is coming. Damn, Abhishek S. Nair, welcome. Okay, okay. Now the thing is with Google Meet that it has such a sweet sound when anyone wants to enter. Okay, when anyone wants to enter that, I just get distracted. Again, someone is coming. Okay, I won't get distracted now. Nevertheless, so I was telling about that when normally my engine is delivering power to the wheels, right, to the front wheel. But if I need more power, if I'm needing peak acceleration, let's say I'm in a gradient, right, at that time I need peak power, then my electric machine will come into play and it will give power to the rear wheels also, and it will give more power. So it is mostly seen in bus, this 2 into 2 hybrid. It is mostly seen in bus because in gradient, like I am downsizing the engine, I am downsizing, first of all I am downsizing the engine. If I'm downsizing the engine, then when I want to climb a gradient, okay, when I want to climb a gradient, okay, at that time, while I downsized it, but while climbing the gradient, I can't climb it with the same power. At that time, my electric machine will work. Okay. Now coming to the post, based on, okay, so many people have came. Time, sir. Okay, okay, I'll just wrap up. I'll wrap up it pretty soon. Only few slides are left. I'll wrap up. Okay. Now,
Okay,
based
no
on
problem. Please continue, sir.
okay, okay. Continuing. There are just people coming and again. I'm again getting distracted. Okay. Where are you? Sagar. Sagar, I am making you co-host. Okay, I am giving you a very, very big responsibility. Okay. Now you will make people enter. Okay. Help me in this. Okay, Sagar. Sagar, where are you? Okay, sir. Yes. Sagar Manani. Jai Sagar. Yes, Jai Sagar. Then if people wants to enter, you will make them enter. Now I don't want to get distracted. Okay. Now coming to pre-transmission hybrid. So in pre-transmission hybrid, what it is that feedbacks are link. Give me attendance link. Array, just wait everyone, wait. You can just give feedback over here. You can give feedback here. Okay. Now in pre-transmission assembly, what is the difference between pre-transmission and post-transmission? Okay. So in pre-transmission assembly, this is my generator motor, IC engine, and here also generator motor assembly. They both are connected in ring, planet and sun assembly. Okay. So all my components, IC engine, ring planet, the motors and the generators, they are used before the transmission assembly. They give power direct to the transmission, the ring planet gear, and then it is delivered to the drive shaft. Okay, this is the use of my pre-transmission assembly. Okay, so here the output shaft of the electric and the IC are connected through mechanical coupling before the transmission. Okay. Moving to post-transmission, in post-transmission, what I have is the electric motor drive is coupled with the output shaft of the transmission. Okay, so in this case, what it is that IC engine, it is connected to transmission shaft. It is connected to transmission shaft. It is continuously delivering power to my front differential. But if I am on a gradient, let's say I am on a gradient, Okay, I want to climb this gradient. Okay, I can't draw good. This is a car. Imagine this is a car. Okay, my drawing is bad. Imagine this is a car. I want to move my vehicle upward. Okay, then IC engine, it is downsized, so it can't produce much power. At that time, what I do is both of them are, then I couple the power of motor to the power of electric, to the power of IC engine. And then it is given, like I am increasing the torque here, and then it is given to the front wheels. Okay, so here I can use my IC engine independently first of all, and the power given to the front wheels is directly given by the transmission without any interruption by the battery or by any interruption of the motor. Okay, so this is about my post transmission. Coming to the degree of hybridization. Based on the degree of hybridization, I have four difference. First is the micro. In micro, the degree of hybridization is less than 5%. Okay, so what is degree of hybridization? Okay, basically degree of hybridization is how much my motor is working, it is giving power, versus how much my engine is giving the power. So the formula of degree of hybridization is it is equal to my motor power upon total power. Now total power includes motor plus engine into 100. This is my degree of hybridization. Next time if you go to any shop to buy a vehicle and if they tell you that this is full hybrid, you can just use this formula, ask them the motor specification, ask them the engine specification, calculate the degree of hybridization, then you'll find the truth. Most of the people, they just tell you the lie that this is full hybrid, mild hybrid. In fact, but on the other hand, they are micro hybrid. Okay, so next time do this. Be a aware citizen, aware customer. Okay. So based on degree of hybridization, in mild, I can have this degree of hybridization to up to 10%. And in full hybrid, I can have a degree of hybridization if it is connected in parallel, then it can go from 10 to 50. If it is connected in series, then from 50 to 75. And electric, it is of course 100% electric. Okay, these are the examples for BMW 1. I have few more points I can share, but due to times, let's wrap up the session fast. Okay. Next time, I'll tell sir my phone is switch off. Please forward the link of the certificate.
Hello, sir.
Yes.
Sorry for disturbing, sir, but I have one question, sir.
Okay. You can use the chat box.
Chat was only, sir.
Yes.
Okay, sir. Okay.
Now let's talk about the future of hybrid electric industry. Okay, in hybrid electric industry, it is expanding. Right now, in 2021, it was an industry of $350 billion. Okay, 350 billion, and it is expanding. And the estimation is somewhat $1,670 billion. At this range, we are expanding our hybrid electric vehicle industry, right? So of course, if we are expanding, new technologies coming in, new engineers are needed in the society, right? New power plants, manufacturing plant, and all the plants has to be manufactured. For that, we need EV workforce. You and me, we are EV workforce. We are learning so that we can work in EV, right? So India is expected to have 30% of vehicle to be electric by 2030, right? And right now we have 23 crore vehicle. Total vehicle is 23. But by 2030, we want about 10 crore vehicles to be electric. Okay. And accordingly, like the jobs that will be created in EV sector, that will be so high. So what can be the jobs in EV? It can be research, R&D can be there, right? R&D can be there. In R&D, chemical engineers, battery manufacturers can be there, material engineers, electrical, electronics, mechanical, software. EV is a blend of all of them. Okay. Nowadays, IT engineer can't come and say that I am superior to you, or EV or mechanical can say mechanical is harder than other branches. Now this is a time to join hands because EV blends everything. EV makes harmony for everyone. Okay. In design and development also we need every engineer, and we need industrial designers also, right? In manufacturing we have so many scope of career right now. We need assemblers, we need CAD controllers, CAM controllers, we need industrial production managers, everything we need. For maintenance we need mechanics, technicians, right? The knowledge right now, we have so many roadside mechanics for normal petrol vehicle, none for electric vehicle, right? We need to train them. They need to be trained, right? We need to build infrastructure. We need to build infrastructure. Charging stations need to be built. Planning engineers should be there. Every workforce should be here, right? That's how we can. If there is no workforce, then why will foreign companies will come and invest in our country, right? The workforce should be skilled enough, right? So that's why we are studying, right? So this is about the session, and there are few things left. We'll try to cover it in the next session. And thank you all for coming here, for being with us. Okay, it means it means a lot. We have 266 people, and 266 people here. Thank you all to everyone. And if you want, we need workforce to work, right? We need workforce to work. So they need to be prepared. They should be aware of the EV technology. I have just told you a tip of the iceberg of EV. The technology is so vast. Okay, what I have taught you till now is just this much. The real knowledge is this much. Okay, there are so many things. This is just the tip of the icebergs. Not even the tip of the iceberg. It is so small knowledge. Okay.
Sir, I have a
If
doubt.
you, sorry? If you want to learn more about these courses, you can visit our website and find out
Hello,
some courses. And yes, yes. Now I am taking the doubts. You will get the certificate. You will get the certificate in the mail. Okay, no worries.
Hello. Yeah, thank you, Pushkar. Thank you for the for webinar. So, guys, we have done with the webinars, and you got through a wonderful session on HEV. So, if you want to learn more about electric vehicle, hybrid electric vehicle, EV technology, then we have one program that is a pay after placement.